required. It doesn't stop, does it? No, it doesn't. It never stops. Now we are going through chapter 4. So let's put it 3.4. Paper 3, chapter 4, and it's going to be differentiation. Remember that we said this is going to be differentiation 2. We'll call this differentiation 2, okay? This is going to be differentiation 2. So differentiation 2, what do you have for us? How many subtopics? 3. 1, 2, 3. Let's see the 3 subtopics, okay? Here they say derivatives, use the derivatives of blah, 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 together with constant multiple sum and difference in composites. Okay, so anyway, in here, we can say that the first thing, okay, this is the first one. So it's going to be 3.4.1. This is going to be what we call common derivatives. So we are going to do common derivatives. They're called common derivatives, okay? What are common derivatives? These are derivatives that we should know by heart. You go in there knowing them. And what are they? It's e to the x, ln x, and then the trig, guys, which is sine x, okay, sine x, cos x, tan x, and only one inverse trig, which is going to be tan inverse of x. So these are the ones. Sine inverse and cos inverse, they are not required, so we are not going to do them because we're going to do only the easy one. You see, this is the easiest, trust me. If you look at the structure, if you look at its formula, it's the easiest. So, this is going to be a walk in the park. But we know that as you keep going higher and higher with your education, when you go to university, you're going to be doing this sine inverse and cos inverse, depending on the program which you're going to study. Okay, but definitely engineering students, you're going to do that. All right, now, so in here we have done, this is common derivatives. These are called common derivatives. So you must know the derivatives of all these. We must have a table where we put the derivatives of all these, and we'll be able to see what they happen when they're in composite form. Composites, we can handle it. I know you can handle it. We've talked about it before. But anyway, let's see 3.4.2. If you're not good, you can go and check your composite, your chain rule. And in here, we're going to be, I'm going to show you how you can apply the chain rule to just these ones, but it's not even hard. All right. Now, let's see, what about this part 2? What is it about? Differentiate products and quotients. So the second one is the part 2 is going to be 2 things. Product rule, okay, 2 more rules. Remember that differentiation actually has 4 rules. And here it's going to be product rule and quotient rule. 2 more rules, okay? So it's going to be product rule and quotient rule. Remember that the first 2 rules are the power rule and the chain rule. Now we had product rule and quotient rule. These are 2 more rules of differentiation, which you're going to have to know, and you're going to apply them. We'll talk about these examples. And then the last thing, 3.4.3, is going to be 2 more things, and that is differentiation of parametric functions and implicit functions. So we can say differentiation of 2 things that are parametric and implicit. So differentiation of 2 things. Number 1, parametric. So parametric functions, and implicit functions. So here, these are the 2 other things we do, and we are done. So what is differentiation 2 all about? Number 1, common derivatives. Number 2, product rule and quotient rule. Number 3, parametric and implicit functions. Then we'll be done. But here, please make sure you see this. It said, including use in problems involving tangents and normals. So, okay. So here, we can put it here. We can put here, including application to tangents and normals, okay? Tangents. So tangents and normals. You must know these 2 words. These 2 words, they say something about the gradient. So you must know, we covered it thoroughly in the first paper, in the paper 1. You can go and see and have a master understanding of these 2 words, because you must know what is it that I get when I differentiate, and you must know when you get your tangent and when you get your normal, and then you can be able to come and apply this when you are done differentiating parametrically or implicitly. When you differentiate parametric functions, there are functions that are called parametric functions, and implicit functions, then you can be able to apply it. Okay, so this is our differentiation 2. It's very tiny, it's very small. You'd be done with it in no time. Now, that is it. Let's get to work. Let's start our work in this thing. It's not even big. I know we can handle it. Goodbye for now. See you in the work.